Now that we have a very firm concept of what's a primitive and what is an object, it's important to start understanding how the computer treats these two types of variables within its own memory, because it actually is going to have a huge impact on how you program with them. Let's imagine this is the computer's memory. It's actually pretty similar to what it looks like. It's a general grid with addresses for each individual location, very similar to an array. When you create a new primitive type of variable, the computer takes a single space in memory and just plops that information right there. The name, the value, all of it. Kind of like this. Now, when you create a new object, the thing about objects is they're dynamic. They can grow and shrink. They might be huge. So the computer has to come up with a very special way to maintain that object in its own memory. So if I were to make a new array, the computer is first going to find a place in its memory to store where else it should store this array. So it's got its own space for the address of the actual information. And then it partitions off a whole section of memory specifically for however big that object is. So now we've got an array sitting in memory where one box is holding the address of where the real data is. This is something that we're hinting at called reference or value semantics. There's a big distinction between primitives and objects. Primitives are all stored directly in memory as soon as you make the primitive. They're so small, that makes most sense. The thing about this is when you change the original variable or you copy it into a new variable, there's no real connection between these. You're just copying numbers over. So if you make a copy of a primitive variable and then change that copy later on, the original doesn't care. Let's imagine we create a new double variable called y, and we store in it the number 5.5. You might visualize that as a little box in memory with the name associated y and then the value 5.5 inside of it. Now I'm going to make a new double variable, this time called z. And it's going to be set to whatever y is set to. Y happens to be 5.5, so the computer makes a whole brand new box with the new name z and copies that original value into it. After this, y and z have no relationship anymore. They're just two completely separate variables. I could change y, z doesn't care. I could change z, y doesn't care. As you can imagine, this means objects function very differently. Rather than partitioning a space for the actual value, objects partition a space for the specific reference to where the object's information is stored. This reference is the address in memory of where things are stored. So let's say I construct a new array called YR, like Y array. You can think of that same little box like we used for the doubles, but now it has an arrow in it. And that arrow is going to point to somewhere else in memory where the array exists. So if I make another array, this time Z array, and we set it equal to Y array, what is copied? Not the whole array, because that might be huge. The computer copies the reference, or that tiny little arrow, meaning that little piece of information for where the array is going to be. Now I have two variables that are pointing at the same information. So if I change something in Z array, it's going to change whatever is going to pull out of Y array, and vice versa. It's the same information. They're just two addresses to the same location. We call how primitives store their information in memory value semantics. This is because the value is what's passed around. So if I construct a new int, and then I construct a new int that is a copy of that int, two separate places in memory. I'm just copying the value. Also, for example, if I was to pass an int in as a parameter, when I get to that new method, the int is just a copy of the original, meaning within the scope of that method, that int has nothing to do with wherever was passed in. That's why in order for ints to reflect changes outside of their initial scope, like say within a loop or within a method, you have to return them. There's no connection, just the values are copied. So what about objects? Let's say I make a new array, and then I make an array that's a copy of it. Now I've got these two arrows pointing at the same information. Whenever I make a change to one, it's going to follow that address to wherever that location is in memory and then change things up a bit. So if I follow the other address to it in memory, it's going to find those changes. Again, they're two addresses for the same thing. You could kind of think about it as an address to a house. Maybe multiple people have the same address to a house. So if you tell one to drive to that house and paint it, if the other person drives to that house, they're going to see a different paint color. You didn't copy the house, you just copied the address for where it is. This starts to get a little tricky when you pass things like arrays around as parameters. So if I construct an array in main and pass it as a parameter into a new method, because I'm passing the reference or the address, whatever changes I make in that other method are going to be reflected back in main. I don't even have to return it. It's going to follow that address, change that original data, and then those changes will be reflected in any variable that stores that address. Understanding how these addresses work is going to be vitally important because sometimes things will change and you won't know why, or they won't change and you're not sure why. Just keep in mind, if you're creating a new object, the name of the variable doesn't actually refer to the object, it refers to wherever the computer is choosing to store that object. So if you're actually trying to make a copy that has nothing to do with the original version, you could use a method, copy of, or you could actually just construct a new array. Anytime you call that keyword new, you're telling the computer, hey, set aside more space in memory. Without the new keyword, then you're just passing around references. You'll get the hang of references as you use them, but sometimes it's easier to draw them out like we've done here. So if you can't tell what's happening, try drawing a picture and make sure you always know where those references are pointing.